All right, this is my lab 3 for physics, looking at the motion of a star traveling around a black hole and then a spaceship being influenced by a planet and a black hole. So, table of contents, we have the introduction, models, data, and observations, code, and then discussion. For the introduction, the purpose of the lab is to create the trajectory of a unique star by using net force, velocity, and mass. The fundamental principle at play here is Newton's second law, or the momentum principle. Through the use of unique glow script code, the black hole's mass can be found, which helps to then calculate net force and initial velocity, and that is the preview of the results. For Newton's second law, it's also known as the momentum principle, states that a force is equal to the change of momentum over the change in time. Here are two equations to represent that. This would be used to calculate initial velocity and the mass of the black hole. So for procedure part 1, analyze the motion of the unique star through glow script code to find net force and calculate the mass of the black hole. And then procedure part 2, use the mass of the black hole found in part 1 to calculate the forces of the planet and spaceship. Use glow script to find initial velocity necessary for the spaceship to avoid being sucked into the black hole. So the initial values, the position of the black hole was the origin, or 000, the mass of the star, 2 times 10 to the 30th kilograms, and the mass of the black hole is unknown. Additionally, I entered my GT email into the code, so that way it would do the randomized star thing. And then it can be assumed that there are no external forces on the system. So system versus surroundings. For part 1, it's the star. For part 2, it's the spaceship. Surroundings for part 1 is the black hole, and part 2 is black hole and the planet. So code part 1, the changes that were made was the mass of the star, which is 2 times e to the 30th, initial and final momentum, change in velocity and momentum, average change in momentum, Fnet, components of Fnet parallel, components of Fnet perpendicular, and then calculating the mass of the black hole. This separated gravity into its perpendicular and parallel components in order to rearrange or calculate for Fnet, which could be used to find the mass of the black hole. I also put in arrow scales so that way it would model properly, and then this seed I put in my Georgia Tech email. So for figures, this top graph represents the mass versus each day because the net force is going to change as it goes through its orbit. And then this on the bottom is the planet in its orbit around the black hole. So using the mass of the black hole, the mass of the black hole was found to be 1.15 times 10 to the 44th kilograms. I used Excel to take the average of all of the masses throughout all the days and then adding them all up and dividing it. So for my code part 2, changes in mass, the mass of the black hole, 1.15 times 10 to the 44th. So I changed planet speed, ship speed, components in the X and Y, net force on planet, net force on ship, then the movement of the spaceship and the planet and how they influence each other. For the figure, the ship on the pink line and then the planet on the blue line, it shows that the ship just barely misses the black hole and is not sucked into its orbit. Since there's no tangible experiment, there is little room for error, but it is possible that a value was incorrectly calculated due to like a mistyped formula in the code. So as far as discussion goes, net force parallel and perpendicular in this case is numerically the same as change in momentum parallel and perpendicular. But the difference, however, is that net force is the sum of all of the forces acting on an object, while change in momentum comes down to change in motion of the object. And what if, to find the initial velocity of the ship to follow an orbit around the black hole, I used trial and error to find which speed the ship would need to be in order for it to orbit the black hole by just fluctuating the speed either greater or lower until it was just barely making the orbit around the black hole. And this came out to be negative 8.4 times 10 to the 13th and 4.81 times 10 to the 11th and 0 in the X, Y, and Z components of its movement. Thank you.